In this tutorial, we're going to demonstrate how to use the Create Job Sheet function. The Job Setup sheet contains all the important information about your toolpath and material setup, and since it is a self-contained HTML file, it can be opened up in any of the latest web browsers on Windows, Linux, Mac and even Android. It can also be printed out for easy access at the machine tool. So why might I need all this information? Well, it's always good to check your settings before running anything on the CNC, and the setup sheet brings all the required information in a single HTML file. This can be invaluable as you don't always have access to open the software on the PC driving the machine tool. Well, during this presentation, I'm going to be showing you how the setup sheet changes depending on whether you are creating a single-sided, two-sided or multi-sheet job. We will also look at how to customize the layout and any common issues you may find when printing out the sheets. So let's go ahead and create a setup sheet. So I'm just going to close down this current HTML file, and we have a session of the software open, and I'm going to open an existing file, and in this case we're going to take one of the existing Vectric projects, which is the widget, and open that file up, and we can immediately see that we're presented with the vectors for this particular project. Okay, so before we move on and take a look at the setup sheets, let's take a closer look at what's contained within this project. I'm going to open the Toolpath tab, which will show the 4 toolpaths in the right hand pane, but I'm going to come back across and just pin open the drawing menu and come down to the layers tab, and we can see that we have 4 different layers and 4 different toolpaths. I'm just going to switch off all the layers now and switch on the recessed rectangles, come across, and we can see that we have the pocketing of those rectangles as shown with the toolpath here. I'm going to switch that off now and come across and switch on the text and come back across and switch on the profile text. We can see that toolpath there, and then across to the drill holes, and we can also see the toolpath there, and finally the outline shape, which we can see there, and we also have the finishing toolpath for that. So we can see that we have a number of different layers and a number of different toolpaths, and those toolpaths are programmed to automatically machine the relevant vectors on those layers. Okay, so with that we can now just switch off those toolpaths and come across to the job setup sheet. So we can see here next to the save toolpath is the create job sheet item, and we can either click on that with the left mouse key, which will ask us to then save that HTML file into a particular location, or we can hold the control key down, which will do exactly the same but then open up the file after it's been saved. So I'm going to hold the control key down and then just click on that now with the left mouse key. It's going to ask me the file name that I want to save it and where I want to save it, and I'm just going to overwrite the existing file here. So we're going to save that now, and immediately we're presented with the setup sheet that's popped open into the browser, and I can take a look at all the settings. Okay, so if we start at the top, we have a simple job layout which has the vectors that we've included from the 2D view, and also the material border, so it shows the size of the material that we're basing our job from. Below that we have the material setup, which of course has the full block size at X, Y, and Z. We can find out where our Z0 is from, whether it's from the top of the material surface or from the machine bed, where the datum is, i.e. in this case the lower left hand corner, and very importantly our home and clearance heights, which are particularly important if we are clamping this particular project. We need to be aware of our clearance to make sure it is going to avoid any clamps or obstacles that may be in the way. Moving down, we can see the next item is the Toolpath Summary. So we've got 4 individual toolpaths there. The names are all listed on the left. Their tool type and size are listed under tool name, and the rough estimate of the time taken to create those or machine those toolpaths. Moving down, we then take a breakdown of the individual toolpaths themselves. So if we take a look at pocket rectangles here, we can see the toolpath type was a pocket based toolpath. We have the all the speeds and feeds there in terms of feed rate, the plunge and the spindle speed. We also just above that have the time estimate. Below that we have information regarding the tool, i.e. the type being an end mill, the name of it being the end mill brackets 0.25 inch, and the maximum cut depth, pass depth and step over. And bearing in mind that if our cut depth is greater than the material depth, which it may well be if we're doing a through cut, then that would show up as red to warn that we're actually cutting through the material and potentially into a little bit of the spoil board. Okay, and once again, moving down, you've got all the other relevant toolpaths listed, and all on the right hand side next to the sort of border that goes round the toolpath, you can see that there is an icon that represents the type of toolpath. So we have here the pocketing, profiling, drilling, and once again the profile again for the cutout. So it gives a very good summary of everything you should need at the machine to make sure you're comfortable with moving ahead and actually setting the material down and starting to cut the job. So with this, I'm actually going to close this down now and show really that if we need to make a modification to the job, and we can quickly resurrect the job setup sheet, and that will be automatically updated. So I'm just going to close this down now, and we're going to theoretically look at this job and say, you know, I've accidentally done something wrong in a particular area that I was going to create the part, and I now need to ideally shift this all across slightly in X and then recalculate all the toolpaths. So with this, I'm going to come across to the drawing menu now and come up to the set job dimensions and origin and just specify an offset. And in this case, I need to shift this a little bit in X. Okay, so I'm just going to shift this across by 1 inch in X and OK that. And it will immediately warn me, would I like to recalculate the toolpaths? Of course I would, using this new offset datum. So I'm going to go yes. All those toolpaths are successfully calculated. And now if I come back and hold the control key down on the setup sheets, let's see the effect and whether there's been any update to the sheet. So I'm going to click on that now, and we'll just overwrite that again, and up pops the sheet. And you can see here in the material setup area that the original area that was left empty is now filled with an offset position, showing that our new work piece is an offset of X1 from the original sort of datum position. Okay, so that just gives you an understanding that it will always reflect the parameters that you are using in the software, and if you do make any changes, just go back and recalculate to update your spreadsheet. Okay, so with that, we're now going to be looking at a sort of multi-sheet setup. Okay, so let's close out of this HTML file and actually close out of this widget project, and we are going to open a new file. So open an existing file, and we're going to take the multi-sheet cabinets.crv, and immediately we're presented on the screen where we have a default sheet in the lower left hand corner and a number of other sheets where vectors have been nested onto. So this started really with us importing a large DXF file and then nesting this onto a series of sheets and then applying a toolpath template to those sheets in order to automatically create the toolpaths. Okay, so with this, I'm going to toggle across now to the toolpath menu, and we can see this series of toolpaths generated. And once again, this was created by applying a gadget which allows us to take a toolpath template and automatically apply it to multiple sheets. And we can see the toolpath naming there. The S1 denotes sheet 1, sheet 2, sheet 3, sheet 4, and we can see they are in sequence. We have all the toolpaths for sheet 1 at the top, the next set for sheet 2, then sheet 3, sheet 4, sheet 5, sheet 6, and all the way down to sheet 7. Okay, so we've got a large number of toolpaths now, and of course we would like to output these ready for machining along with the job setup sheets. But of course, bearing in mind these will all be separate sheets, then we need a separate setup sheet for each one of those sheets. So we can come up to the job sheet command, and rather than holding the control key down and trying to open up several HTML files, I'm just going to click on this now, which will then generate the HTML. So it's just going to ask me where I want to save them. So I'm going to put them in the same folder location as the widget one that got created. So I'm going to save that all now, and then we're going to pop back in and open up Windows Explorer to show those files that have been created. So we can see that we have sheet 1 through to sheet 7. Okay, and we're going to start by opening up sheet 1. So I'm just going to pop that open now, and immediately we can see the job layout for that particular sheet. And of course, if we remember, there was only one particular toolpath, which was the profile cut. So all the same information that we saw with the widget is included. We also, in this particular job, have some notes applied, which will be across every single sheet, which is this job should be ran with grey, beige, Sobrano, lightweight furniture plywood. Okay, and of course we can have notes with the individual toolpaths, and they would also be shown if required. So this gives us a quick heads up on just sheet 1. Now if I actually close that down and I'll open sheet 2, which of course has way more toolpaths. So I'm just going to pop that open now. You can see that we have a different material layout at the top showing the vectors. And of course, if we go down to the Toolpath Summary, we have a large number. There are 8 different toolpaths, and we can see the sort of summary breakdown and then the entire breakdown for each individual one below that. Okay, so we can see that it's very quick and easy to generate the setup sheets. That was just one click that took care of generating all 7 sheets for the whole project. So I'm now going to close out of this now, and now we're going to take a look at how we deal with a dual-sided project. Okay, so let's go ahead and close out of this file and open an existing one and pick the CoolCube toolpaths.zrv file. And we're currently looking at the top side of this multi-sided project. If we come up to the top menu, we can now toggle between the top and bottom side, so we can see the bottom side and a different set of vectors being used, and therefore a different set of toolpaths. I'm now going to toggle back to look at the top side vectors. To the left of this is similarly important. This is the flip direction, which shows which way we need to flip the project when we go ahead to machine the bottom side. In this case, we'll be flipping it around the y-axis. Okay, so moving across now to the toolpath menu, we now need to consider the job setup sheets. Well, of course, we have 2 different sides here, the top and bottom, with a different set of toolpaths on. So this will need 2 different job setup sheets. So with this, I'm going to come across and click on the job setup sheet command, and immediately it's asking me for the name. In this case, it'll be CoolCube Toolpath Summary, but it will append at the end which side, whether it's top or bottom. So let's save that out now, and if we pop into a Windows Explorer, we can see that CoolCube's Toolpath Summary top has been created, and if we click on that now, we will get some information relating to the project for the top side. So we've got the job layout at the top, which is the view that we saw, which will show obviously the material size and all the vectors that we had listed. We've got some important notes there which came from the main notes for the particular project, and then below that we have the material setup. Now you'll notice that 2 additional items have been added, which are the side that we are currently dealing with. In this case, we are looking at the top side as shown by the arrow pointing to the top of the block. And then of course to the right hand side, we have the flip direction. So these 2 items have been added to the material setup based on the fact that we are dealing with a 2-sided project. If we scroll down, we have the same toolpath summary and then the full list of toolpaths. And one thing to note with the drill toolpath here is the fact that the max cut depth is actually shown in red at 0.75 of an inch. And of course, if we come up to look at the block thickness, that's currently ½ an inch. Now, it may be with some toolpaths that we will just cut through if we're going to do a profile cut, or in this case, we may be creating a longer drill hole in order to be able to place some pins for a 2-sided project. But it is worth noting that the red will denote the fact that we are cutting through the material into the spoil board. So with this now, I can close out of the top side and then come up to the top menu and select the bottom side and come across and generate the job setup sheet for the bottom side. So with this, I keep the same name, and then I'm going to pop into Explorer, and you can see that the extra HTML file has been created. I'm just going to double click on that to open it up, and we can see that our vectors have changed from the top to the bottom side. We've got the same job notes. We are currently now looking at the bottom side. The flip direction is also still specified there. And of course, our toolpaths will be different, bearing in mind we're dealing with the bottom side and not the top. So that gives us a really good understanding of the differences between working with a multi-sided project in this case, but we looked at a multi-sheet view, and then we looked at a standard single-sided project as well. So we've covered all 3 bases there, and now we're going to move on to look at some issues with what you may face when printing some of these sheets. Now, the issues faced with printing may be different depending upon the web browser. In this case, we are using Google Chrome, and in order for me to print, I'm just going to either select Control P on the keyboard or right mouse key print. and in which case I get presented with a preview on the right hand side and a number of settings on the left hand side. Now with past editions of Google Chrome, sometimes the background images wouldn't be displayed, so we would be left with sort of blank spaces on our material setup. But in this case it has printed that out. But in case yours doesn't do that, then if you go down to more settings, you may need to select background graphics and click this on in order to show the background images. Similarly, you may be showing headers and footers at the top and bottom of the page, in which case you would need to ensure they were switched off. And also it may be that you want to maximize the margin. So if you come up to margins and from the drop down move away from default and go down to none, as you can see there, the margin almost disappeared at the top of the page, and that will also automatically remove the headers and footers by changing that margin. So these are just some of the settings that you may need to go into in order to be able to format the page in the way you would like before printing. So just please be aware that these could be different depending upon the different web browser that you are using.